respiring, how much of it they're actually using up. And the only way that you can determine that is, check this out, it's rather clever. You could take some of the plant material, in other words, sample the water. Let me try to draw this. So you could scoop up the water and put it in you can put it in a container like this. You can put it in a water bottle like that. Okay, so here it is. And inside of it, there's obviously some plant material like this. And you can measure the amount of oxygen in the water. But check this out. If you took the same bottle and you put some aluminum foil around it, or put it in some sort of opaque material around it, in other words, you're blocking off the sunlight. So if you block the sun, so there's no light penetrating into the bottle, what you can do over a set period of time, let's just say it's 1 day, what you could do is you could initially determine the amount of dissolved oxygen in the water. Okay? So let's just make up some numbers. Let's say that initially the amount of oxygen in the water was 10 parts per million. There's the units, parts per million, initially. And then after 1 day, since they're not producing any more oxygen, because you've darkened the bottle, they're only respiring. So in 1 day, you sample the water again, and guess what? There's less. Predictably, there's 8 parts per million. And so, interesting. So the plants are respiring. So how much did they respire in 1 day? That would be 2 parts per million. So if the respiration is 2 parts per million, and you originally measured 10, that probably means that, the gross primary productivity is in fact 12. So it was making 12, using 2, therefore 10 is available, and that's the net. 10 is available. Available for what? Available for fish. Well, I say fish, but really any consumer. And so photosynthesis and respiration play an important role in primary productivity. Okay, but there's some other, those are biotic factors. There's some other factors as well that contribute to the amount of oxygen in the water, and this has to be considered. There's some abiotic factors in addition to photosynthesis and respiration. So this may be just totally obvious. Again, a person on the street, if you ask them, hey, what's influencing oxygen in the water? And they're like, the first thing they might say is, well, look at this. The water is turbulent. It's rushing over these rocks in this sort of ripple zone right here of the river. And so waterfalls and wave action introduce oxygen into the water. And so that's a physical phenomenon, that it's windy and the rapids introduce high levels of oxygen. They may not mention photosynthesis and respiration, but this is a physical factor. So in other words, turbulence and winds. And let me throw in a couple other ones. You may not be aware of the fact that temperature, and this could be experimentally observed in the lab. So you can literally look at the effect of temperature on how well the water holds on to dissolved oxygen. When I say dissolved oxygen, I don't mean H2O. I mean molecular oxygen. I'm talking about like this. I'm talking about O2 in the water. Think of it as like dissolving sugar into the water. You're dissolving oxygen in the water. How about this? Colder water holds more oxygen than warmer water. So cold water, you can look at this. So if it's colder in the water, there's going to be more oxygen. And so obviously I mentioned this in detail. Photosynthesis, photosynthetic activity, if there's lots of light shining into an area, you can expect more oxygen to be produced, because that's what's producing it, is the energy from the sun. Now, decomposition, this is a curious one. So as organic material like sugars decay, if there's too much decomposition, in other words, there's a lot of bacteria in the water, decomposing, in other words, breaking down the algae, as it turns out, the bacteria, let me see if I can draw that in there, the bacteria, if there's a lot of bacteria in the water, and this could be a problem, they're not only breaking down the sugar, but they're respiring. Bacteria are not photosynthesizing, so they're actually consuming the oxygen and the sugar in the plants, and so they're reducing the oxygen. So if there's a lot of algae decomposition in the creek or in the lake, the dissolved oxygen should be going down because they consume it. So that's a concern. If there's a lot of algae bloom, then ultimately the dissolved oxygen will go down. And you're like, again, you need to come in with the attitude that this is important to care about, meaning that, okay, dissolved oxygen in the river, whatever. But no, the fish are going to die, and so that's fairly critical. And so salinity, how about this? This is, again, just a physical factor, the fact that salinity affects the amount of dissolved oxygen that the water can hold. So fresh water holds more oxygen than does salt water. So as the water becomes more and more salty, more and more warm, more